Okay guys, so for today's lesson we're going to look at ionic bonding. We're building on what we did in our last lesson where we looked at the formation of ions, and we're now going to look how they bond. It's going to follow the same structure, so as always you're going to need something to write with, something to write on, and your attention span. Focus on what we're doing. And as for you guys should be getting quite good at this now, using this video lesson. Pause it, answer all the questions and check your answers. Okay, through retrieval and independent practice. Pause the video as soon as it pops up and have a go. And rewind and rewatch the explanation as much as you need it. If you're getting stuck on any of the independent questions, just go back, rewind, watch through that explanation again. Here's the periodic table for reference. You can rewind back and use that if you need it. And now let's get started with retrieval. Okay guys, I want you to start by thinking about when you've used magnets before. And we know they've got a north and a south pole. And now when you use those magnets and you put them up against another one, sometimes they'll push apart, sometimes they'll stick together. And we know that kind of depends on which of the poles you're using. So if you have the magnets this way around, two like poles, you'd expect them to push themselves apart and repel. Whereas if you swap them around and have opposite, they stick together and they go really close, and it's hard to pull them apart. It's quite difficult. Now, ionic bonding works in a kind of similar way. So it's between the ions of metals and non-metals. And we know metals on the periodic table, you find them on the left-hand side of that stepped line. So metals on the left and non-metals on the right. From last lesson when we looked at ions, we knew that the metals formed the positive ions and non-metals formed a negative ion. And it's that opposite charge, similarly to what I was talking about with the magnets, that sticks them together and holds them together. It's because they're oppositely charged, like a north and a south pole sticking together. So let's have a look at an example. We're going to look at sodium chloride, NaCl. So this formula, it doesn't have any numbers in there, so it tells me that I have one atom of sodium and one atom of chlorine. I'm going to start by drawing those atoms, same as we did in the very first lesson. I'm not going to worry about the ions yet. So when we're drawing out the atom, we just look where it is on the periodic table. So sodium, Na, is in the third period and group 1. So the third period tells me it's got 3 shells of electrons. The first group tells me it's got 1 electron in its outermost shell. And then we just fill in the rest below. Okay, for my 1 atom of sodium. I'm also going to draw out chlorine. I'm going to do this one slightly differently. Instead of drawing the crosses, I'm going to draw them as circles. They're still electrons. There's nothing different about the electrons. I'm just going to draw them as circles so we can see that it's clearly a different atom. Again, chlorine, period 3, so 3 shells. And it's in group 7, so 7 electrons in its outermost shell. Let's fill all those in. Okay, now going on from last lesson, we should all know what's going to happen to sodium to form its ion. It's going to lose that electron, and chlorine is going to gain an electron. And when we were doing these last lessons, you might have been wondering where on earth does that extra electron come from for non-metals. Well, hopefully that's really clear now. Our metal loses and our non-metal gains. So they'll form their opposite ions, and those opposite charges are going to stick them together. And we're going to show that by drawing the ions next to each other. So sodium ion now only has 2 shells. We draw those square brackets to show that it's an ion and no longer an atom, and we put in its charge, and then we do the same for chlorine. Putting in its electrons, and now it should be really clear why I've drawn one atom with circles and one with crosses, is that now we can clearly see where that electron's coming from when we draw them out bonded together. So that's sodium chloride, the opposite charges, sticking them together, both atoms now more stable because they're in their ion form with full outer shells, stuck together with that opposite charge. And we call that force of attraction between them an electrostatic attraction. Electrostatic attraction, and that is between positive and negative ions. Okay. Okay guys, I'd like to give yourself a chance to embed and self-test that knowledge. Go back, if you didn't write anything down, take some notes from what I drew under the whiteboard, pull it into your books, cover it up, get someone to self-test you on that. You need to know electrostatic attraction. You need to know the steps to go from drawing that atom to then drawing how the two are bonded and how it's being lost. Let's have a go at embedding that now. Okay guys, now I'd like you to have a go at the following questions. So we've got some different atoms there, and they're going to form different ions and combine together. We should have already drawn these ions before from last lesson, so that's a step you've got for you. You now just need to look at how they're combining to form their compounds. So have a go at drawing those diagrams, rewind, have a look through that explanation again if you're not sure, and have a go at these questions along with the explanation. That might help you to do it if you're not quite sure. And then once you've done those first 3, everyone needs to have a go at the challenge ones below. Okay, and then for our challenge ones, we've just got, instead of 1 electron being transferred across, we've now got 2 electrons being transferred across, so making those full outer shells. That's all for today. Hope you guys got on with that and did really well. And I'll see you next time.